So very quickly, we look at the potentiometer. Potentiometer circuit. When we talk about potentiometer, potential is from the word potential difference. Potentiometer means that the potential difference is changing with length. So we can say that a potentiometer is actually a potential divider circuit consisting of a variable resistor whose resistance is changing with length. And you know that if resistance changes, then the P that across the resistor will also change. That is why we said potentiometer is actually a potential divider circuit that contains a resistor whose resistance is changing with length. That is a variable resistor, and therefore the P across that resistor will also be changing with length. So how does the potentiometer circuit looks like? It consists of a uniform wire of length AB. To that wire, you have a driving cell. This driving cell has an internal resistance R. Then let's put another resistance here. Let's call it R. So if the EMF of the driving cell is E1, internal resistance of this resistor is what? Is R1. Then I have a battery of EMF E2 having internal resistance of R2 connected to a galvanometer. The galvanometer is connected to a jockey. So I put this in a box. Putting them in a box means that this resistance belongs to this EMF. So that is basically the internal resistance of this of this battery. Is that clear? That is basically the internal resistance of this battery. So point C is called the contact point. So we can say that AC is a resistance wire having resistance R substitute AC. CB is also a resistance wire having resistance R substitute what? BC. Let me move this place to A, this to B, C, D, and E. If you look at this circuit, we have three possible loops there. I have this loop A, B, D, E, B, like this. I also have loop B, C, B, like this. I also have the bigger loop A, B, C, D, E, A. So this driving cell supplies current I to this junction. At the junction, the current will divide. Let's say current supply is I1. It divides into I2 and what? I3. By using the junction rule there, which is the Kirchhoff's current law, I can say that I1 is equal to I2 plus what? I3. So if I look at this loop, for loop AB, D, E, A, if you go around this loop, according to the loop equation that I've explained before, this becomes minus E1 plus the PD across BC. That becomes plus I2 resistance of BC plus the PD across CD. That becomes, remember that the current entering this junction is I2. Current entering this junction is also I3. So I can say current leaving is I1. So the PD across this becomes I1 times the resistance of what? CB. Plus the current through this resistor is I1 times R plus the PD across the internal resistance, which is what? I1 R is equal to 0. If you take the EMF across the cosine, that becomes E. E1 becomes I1 into resistance of CB plus R plus the internal resistance plus I2 resistance of BC. If you look at this smaller loop, for loop BCB, I'm going to have E2 plus the P across R2, I3 R2, but the loop direction there is opposite to the current direction. That becomes minus I2 resistance of AC is equal to 0. So E2 plus I3 R2 is equal to I2R resistance of, I said AC, resistance of BC. Resistance of BC. Okay, now if you take the bigger loop, I'm going to have minus E1 plus the P across the internal resistance I1 R1 plus E3, I say E3, E2 plus the P across R2, which is I3 R2 plus the P across RCB plus I1 RCB plus the P across R plus I1 R is equal to 0. So if I take EMF across the cosine, I'm going to have E1 minus E2 is equal to I1 into R1 plus resistance of CB plus R plus the P across the internal resistance of this one plus I3 R2. Let's call this one equation 3. This is the first equation 1, this equation 2. Now what happens in a potentiometer is that the contact point or the jockey is moved until the galvanometer gives a null deflection. The contact point or the jockey is moved until the galvanometer gives a null deflection. When the galvanometer gives a null deflection, there is no current in this wire. So I can say that I2 is equal to 0. I3 is equal to 0. So from this equation, I1 becomes I2. So the contact point or jockey is moved until galvanometer gives null deflection. If the galvanometer gives null deflection, that means that I3 is equal to 0. There's no current in this wire. So that I1 is equal to what? I2. So this equation, that point is called the balance point. Balance point. Why is it called the balance point? Because if there is no current flowing through this wire, then the PD of resistor wire BC is balanced by the EMF of this battery. You are going to see more of that. So if I simplify that, I2 becomes equal to I1. So E1 now becomes I1 into resistance of CB plus resistance of BC plus R1 internal resistance plus, that is plus R1, which is this one, plus R. Okay? Okay? And you should know that resistance of CB, the result of CB, I says this should be CD, sorry. This is, okay, I changed some things there. Please note that this place was A before, I changed it to B. So this is actually BC. And it's actually CD because I've changed this one to D. So this is the resistance of BC plus resistance of CD. Okay, please take note of that. So this is actually resistance of CD. Did we correct it there? Resistance of, for this one is resistance of CD also. Okay, I think that was good. Resistance of BC plus resistance of CD. Okay, resistance of I2 before times resistance of CD. Oh, I'm correct with this one. I've corrected the BC. BC, yes. That's CD, that's BC. So I can now, when I1 becomes I2, I2 is now equal to I1. Then this equation becomes this. So I can say that the resistance of CD plus the resistance of BC will be equal to the resistance of BD. So RCD plus RBC will just be equal to resistance of BD plus R1 plus R. Okay? Then also, for this loop, we have said that I3 is equal to 0. Therefore, E2 is equal to I2 times resistance of BC. So the point I was explaining there before is that this point is what is called the balance point. So when the galvanometer gives a null deflection and there is no current in this wire, it means that the EMF of this battery is balanced by the resistance of the resonant wire across the battery. So when the contact point is moved until it gives a null deflection, at the point of the null deflection, the EMF of this battery is balanced by the resistance of this resistance wire, which is a very useful application of the potentiometer. So I can find the EMF of this battery if I know the PD across wire BC, where the galvanometer actually gave a null deflection. And I can do that easily, because I2 is now what? I1. Because I3 is equal to 0. I can easily find I1, which is the current supplied by the battery in this circuit. That's the current supplied by the battery. And if I know I1, then I can know the PD across this resistance wire BC. So the PD across the resistance wire BC is balanced by the EMF of this battery at the balance point. So E2 now becomes the PD across BC. Note that. Very, very important. At the balance point. So I can also say, replace this with another battery of EMF E3 having internal resistance R3 connected to the galvanometer again, and it moves until it gives a null deflection at contact point C prime. When it gives a null deflection at contact point C prime, also, that means that the PD across BC prime is balanced by the EMF of the battery E3. So I can also say that E3 is equal to PD across BC prime, where this other galvanometer gives a null deflection. And I can now find the ratio. That is E2 over E3 is equal to PD across BC over PD across BC prime, which is equal to I1 resistance of BC over I1 resistance of BC prime. Current can take current, and resistance is proportional to length. Length of BC over length of BC prime. Okay, so when the galvanometer gives a null deflection, the resistance is proportional to the length there. So if you know the length of the resistance wire when this battery produces a null deflection, I know the length of the resistance wire BC prime when this battery also produces a null deflection, the ratio of this length will be equal to the ratio of the EMF of the battery. So if I know the EMF of the first battery when it gives a point of null deflection, I can use this relationship to find the EMF of the second battery.